Good. Welcome, everybody. My name is JD Maloney. I'm a storage engineer at NCSA. We currently run a system called Blue Waters. It's a large cray system, but going forward here, we have a lot of interesting projects coming up to NCSA that generate a lot of big data that we have to figure out how to handle for these projects. So just to give a brief overview here on big data, we see this growing a lot. All these sensors that are being deployed every year, they're getting more and more resolution. Sensors are getting higher and higher resolution that are cranking out more data. And also advances in robotics are aiding that data capture by allowing us to make these sensors more useful. So sensors can be moved more quickly and precisely between capturing images, which allows us to increase our data flow rates. So that increased frequency also comes. Also, new science domains are leveraging these sensors, so not just some of the historical science domains that we're used to. Some new science domains are actually doing in this stuff. So like agriculture is really making a big dent in sensor technology. So also new software tools, AI is a big thing. These new algorithms are creating a lot of data and also demanding a lot of our file systems to get data input to them to train models and stuff like that. So we kind of are categorizing big data into the 4 V's here. So it's volume of data, right? The veracity, how many different types of data that we're bringing in from all these different industry verticals that we have to handle. The velocity at which it comes in, like I mentioned, we're gathering data at a lot higher rates, and then also just how trustworthy is data. So as we get into like medical research and stuff like that, the integrity of this data is also being very important. So some of the big projects that NCSA is embarking on right now with some different people is capturing data from one is LSST. If you have anyone here heard of LSST before? Is anyone interested in astronomy? No? Okay, it's a large telescope that's getting ready to go on the mountain here in Chile. It almost looks like that right now, minus the dome on the top. We're completing construction right now on that. That's going to have a 3.2 gigapixel sensor on it that's going to fire twice a minute down every night in Sierra Pachón, Chile. And so that will generate about 15 terabytes of raw data every night that we have to process just from that instrument alone. And from that 15 terabytes, we're going to derive an extra 75 terabytes of data via various pipelines for scientists. Some of those pipelines need to be turned around within 60 seconds of image capture. So we have 60 seconds to get the image off the scope, down through Chile, up across, into the North American continent, into our data center, process it for alerts, and actually spit out alerts to science members. So not only do we have a lot of data coming in, we got to process it really quick. So this telescope will be observing for at least 300 days a year for about 10 years at least at this point. So we're talking petabytes and petabytes of data. We're actually going to be building the data center in Chile there. There's going to be a Chilean data access center that's being constructed now also. So not only are we managing the data that's in our facility, but we're also managing data down in Chile remotely. So that's a big project that we're embarking on. Also another one here we're working with is TerraRef. This is done out of the Department of Energy. Bill and Melinda Gates Foundation has some play in this also. And so this is a giant robot. I wish there was a human in this picture for scale, but it is many stories tall. And it's a 30-ton machine that travels along a 200-meter rail system. They're getting ready to extend it to 400 meters, so we're even going to get an even longer scan path here soon. And this scans the field every day with 11 different sensor types, and those sensor types can generate about 3 terabytes of crop image data per day that we're stitching together, doing hyperspectral imaging on, and that allows these people to actually watch these plants grow in 3D in real time and track things like biomass and other things to figure out which varieties of species are best for different drought-resistant conditions. And so this is located actually in Arizona. We're in Illinois, but we have a link between Arizona and NCSA, so in real time they're relaying this data up to us. And this, because we're in Arizona, we get up to 3 growing seasons per day, 3 growing seasons per year. So you have 2 full normal growing seasons like you think about, and you also get a small fallow season in the winter that we wouldn't get if we planted it up in the Midwest where most crops are normally grown. So that's a large sensor that we're getting data from also every day. Also, NCSA has a very large industry program that we house, and so there's a lot of different growing data sets from there. Genomic data is huge right now with all the DNA sequencing that's going on. You have a lot of industry partners that are doing DNA sequencing that's growing fast. Also, new sensors for crop data, like I talked about, the TerraRef is one of them, but we also have private industry projects that are leveraging a lot of data growth also, as well as growing HIPAA and PHI data sets. We have some medical customers that have a lot of PHI data that we need to keep track of. And our industry program as a whole, when I plotted it on our graph the other week, we're growing at 4 terabytes of data per day at least. And so keeping up with this data growth is also pretty intense. I believe lastly we have the Dark Energy Survey. This is a camera that's down on another mountain in Chile that's already under production. So it has a 496 megapixel sensor, and it produces only about 500 gigabytes a day raw, but we also derive about 2.5 terabytes a day from that data as well as a byproduct. So it's finishing up its 6th year of survey, so we have 6 years of survey data from this telescope down in Chile that we have to keep on our file systems and serve to the public. So that's another big deal. Oh, and also we have data sets from a couple NASA satellites. If you're familiar with the Terra satellite that's currently orbiting Earth, it has the sensors for the MISR sensor, the MODIS sensor, and the Aster sensor. And data from those sensors come to NCSA also, and we've been working on repackaging that data as well. And so that is about 3 petabytes of data set right now, 1 petabyte of raw data, and about 2 of derived data. And this is increasing at about 60 terabytes a year for the raw and 120 for the basic fusion data that we create. So NCSA uses DDN for a lot of our stuff that we run on. We've been working with DDN for 15 years already. We worked with them a long time ago. Our first file system with them was on our tungsten cluster. At that time it was a whopping 11 gigabytes a second, but this is in 2003 running luster like 0.6 or 0.9 or something like that. So way back in the early days. So we're continuing that strong relationship with them, and currently over half of our capacity in our data center actually runs on DDN storage. So right now, hardware on the floor for us, we have about 4 14KXs, 3 12KXs, 2 12KXEs, 7700X, and 4 12Ks that we're about ready to retire. So we have a lot of DDN on the floor right now, and we're getting ready to replace some of that stuff as it goes. As data growth continues, we're going to be bringing another couple 14KXs online and maybe some other stuff soon. So we kind of take our architecture into 2 different types. We have a high-performance cluster architecture that we use right now, where we get SFA appliances from DDN, and where you see here I have like our scale-out method, how we continue to grow this over time. And so we use their block appliance. We have an EDR InfiniBand SAN that backends our data center. It's our data center storage fabric. And then we roll our own GPFS and SD servers ourselves using Dell or HP or Lenovo hardware, depending on what we're going with. And we take those NSD servers. Sometimes we also have LROC caches, if you guys are familiar with Spectrum Scale. It supports local read-only caching, and so in some of our high-performance environments, we actually put LROC out in the nodes for them to use also. Also, I mentioned HIPAA data a lot. Also, we have a same type of architecture, but there's some changes to it. We add SED encrypted drives to our DDN units. So we have that for our self-encrypting partners who want to make sure their data is safe at rest. We also use audit logging in Spectrum Scale v5. We can ingest hundreds of thousands of file changes per second on audit logging to maintain HIPAA and PHI compliance. And then we have right now over 9 petabytes of HIPAA compliant storage online in the data center right now. So our medical group is really growing strong at this point. And lastly, we have our high efficiency storage, which is based on DDN's embedded products. So the 14K XE or the 18KE. And those just hook up to our core Ethernet our core Ethernet fabric in the data center directly. That saves us a lot of cost on having an InfiniBand interconnect. And also, because it's an embedded appliance, we don't have to have any external NSD servers. So these are embedded, they run Spectrum Scale. We connect in at 40 or 100 gigabit, depending on what the appliance is. And then our clients mount via remote cluster mounts of GPFS. And so that allows us to grow and scale multiple projects within one environment. And that allows us to also decrease costs, both on hardware by not having to have external NSD servers, external switching, but also allows us to save costs on hardware licensing. So that's another boon for us also. So in the future here with DDN, we're working on implementing some new products in the industry. Obviously the 18K that was announced this week, we're looking at bringing one of those into the data center here soon. Also, we have some upcoming AI projects. One of our fellows just won an AI award from the NSF, and so we'll be deploying that and looking at using the A3i for that type of system. And as DDN continues to roll out new stuff, we look to partner with them as they do so. That is all I have. Are there any questions?